Welcome back to our chemistry class. Today we can discuss establish the relationship between Kp and Kc. Our learning objectives to learn about relationship between Kp and Kc. Page number 6, second volume. Page number 6, relationship between Kp and Kc. This is one of the book bag question. Question number 28. What is the relationship between Kp and Kc? Give one example for Kp is equal to Kc. One of the very important question, 5-mark question. Here, relationship between Kp and Kc. Let us consider the general reaction in which all reactant and the products are ideal gases. We are taking one of the equilibrium reaction, that is X moles of A plus Y moles of B gives L moles of C and M moles of D. Here all the reactants and the product, reactants means A and B are the reactants and C and D are the products, am I right? For the forward reaction. And also we have the reverse reaction. It is one of the equilibrium reaction. Here all the reactants are the products are ideal gases. What is about an ideal gas? An ideal gas is a gas with a very simple relationship between pressure, volume and temperature. A simple relationship between pressure, volume and temperature, that we are saying an ideal gas. Here one of the equation, A plus B gives C plus D. The coefficient we know X, Y, L and M. First we have to write equilibrium constant Kc. How will you write the equilibrium constant Kc? The previous video we discussed. How will you write the equilibrium constant Kc and Kp? Everything we discussed. Now once again we can discuss how will you write the equilibrium constant Kc. Here Kc is equal to, whenever you are writing one equation, first you have to write the Kc, product divided by reactant, product divided by reactant. Here product is C and D are the product, am I right? C and D are the product and the reactant are A and B. So always you have to write product divided by reactant, okay? So Kc is equal to C, active mass of C, that is a product, into active mass of D. This is the product. Then you have to write the coefficient, that is C power L, D power M, divided by the reactant. Which are the reactant here? A and B. Active mass of A, active mass of B. How to write the power? That is coefficient X and Y. You have to take as the equation 1. So how will you write the Kc? Kc is equal to C power L, D power M, A power X, B power Y. Here the square bracket denotes that active mass. Otherwise we can say that on molar concentration, molality. These are all the name for this. So how to write Kc is equal to C power L, active mass of C power L, active mass of D power M, active mass of A power X, active mass of B power Y. Am I right? Always you have to write product divided by reactant. Product divided by reactant. Next, how will you write Kc? Kp. We wrote in Kc. Next you have to write Kp. Kp is equal to, same like that, we have to denote in partial pressure, with partial pressure of C power L into partial pressure of D power M divided by partial pressure of A power X into partial pressure of B power Y. Okay, this is equation number 2. So first you have to write equilibrium constant Kc. We have to write product divided by reactant. Always product divided by reactant. First you have to write product divided by reactant. So equilibrium constant Kc is equation 1 over. Partial pressure Kp 2 is equation 2 is also over. We know an ideal gas equation. One of an ideal gas equation, PV is equal to nRT. We know that, we learn in small classes. Ideal gas equation, PV is equal to nRT. What is about the P? P means pressure. It denotes pressure. What is about the V? V denotes volume. Volume, and n, a small n is about that, the amount of the substance, and R, capital R, ideal gas constant, and T is the temperature. So ideal gas equation, PV is equal to nRT. This can be written as P is equal to N divided by V into RT. Here we know that already we discussed the last video, active mass, the other name of an active mass is a molarity. Active mass is defined as the number of grams mole per liter. Already we discussed. Active mass is equal to molar concentration. Active mass is equal to molar concentration, that is equal to N divided by V. N means number of moles divided by volume, N by V. So P is equal to N by V, am I right? So P is equal to, we can put it as P is equal to active mass into RT. P is equal to what? P is equal to active mass into RT. Here active mass means concentration in terms. Okay, concentration, molar concentration. Don't forget that. Okay, here as per this we can be written as for partial pressure of all reactants and the product, partial pressure of A, partial pressure of B, partial pressure of C, and partial pressure of T. As per this you have to write one expansion like that. That is, first we have to write partial pressure of A raised X, partial pressure of A X is equal to, that is, don't forget that we are applying here active mass here, concentration of A power X, RT power X. Okay, whenever writing partial pressure of A power X is equal to, here active mass of A power X into RT power X. Second one, while we are writing the partial pressure of B power Y, how will you write? Partial pressure of B power Y. Have to write active mass of B power Y RT into Y into RT power Y. Okay, yeah. So this square bracket means active mass. Don't forget that the square bracket denotes active mass or molar concentration. Okay, next one, partial pressure of C power L is equal to active mass of C power L into RT power L. Next one, partial pressure of D power M is equal to active mass of D power M into RT power m. Okay, don't forget that this value here. Partial pressure of A power x is equal to active mass of A power x into RT power x. Partial pressure of B power y is equal to active mass of B power y into RT power y. Partial pressure of C power L is equal to active mass of C power L into RT power L. Partial pressure of D power M is equal to active mass of D power M into RT M. These are the values. These values we have to substitute in equation number 2. Okay, we know the equation number 2 is a Kp. Equation number 1 is Kc. Kc means equilibrium constant. Kp means partial pressure, equilibrium partial pressure. So we have to this value applied in where? Equation number 2. What's equation number 2? Kp is equal to P C power L, partial pressure of C power L into partial pressure of D power M divided by partial pressure of A power X into partial pressure of B power Y. This is the equation number 2. This value we have to substitute in equation number 2. What is our expected answer? Kp is equal to, we can written as Kp is equal to, in the equation number 2 we have P, partial pressure of C power L, partial pressure of C power L. So we can be written as partial pressure of C power L is equal to, what is the answer? Active mass of C power L into RT power L. Am I right? Second one, partial pressure of D power M. What is about the partial pressure of D power M? That's also we have right. Active mass of D power M into active mass of D power M into RT power M divided by, next, partial pressure of A power X value. What is partial pressure of A power X value? Active mass of A power X, active mass of A power X into RT into X, and about the next value, partial pressure of B power Y value, active mass of B power Y into RT into Y. So we substitute this value. Here we have to write on next one term, Kp is equal to, what is the next one here? Here having 2 RT, am I right? 2 RT term is here. One is RT power L and RT power M. So this power we can be add and we get the value is, we can be right, C power L D power M. Here 2 RT value, I am taking the power, we have to add it here. So RT into L plus M divided by A power X B power Y. Here also we have 2 RT terms, okay, because it is a multiplication term, we can add it here. RT into X plus Y. Okay, so here the RT power X plus Y is in denominator, we can be take it in a numerator, so it become minus, right? So Kp is equal to C power L D power M divided by A power X B power Y into RT we can be written as L plus M minus X plus Y. Okay, the denominator, because RT X plus Y is in denominator, we can take it a numerator, so it become minus, right? So just now we can become this equation, we can be taken as equation number 3 like that. Equation number 3, just by comparing the equation 3 and 1, we can compare the equation 3 and 1. What is the equation number 1? Kc is equal to active mass of C power L, active mass of D power M divided by active mass of A power X, active mass of B power Y. Am I right? So that is equation number 1. In equation just we are comparing this C power L, D power M, A power X, B power Y. Am I right? This active mass we can be written as Kc. Am I right? This term, this is active mass of C power L, active mass of D power M, active mass of A power X, active mass of B power Y. This can be written as Kc. Am I right? As we are comparing equation 3 and 1. So Kp is equal to Kc, here are RT, L plus M minus X plus Y. Am I right? So here L plus M minus X plus Y can be written as, this term can be written as delta Ng. Here what is the meaning of delta Ng? That is the differences between the sum of the number of moles of product. The difference between the sum of number of moles of the products and the sum of moles of the reactant in the gaseous phase. We can be simply say the number of moles of product minus the number of moles of the reactants. Okay, so that we can be written as delta Ng. So the above expression we can be written as Kp is equal to Kc RT into delta Ng, RT power delta Ng. Okay, this is the expression for Kp and Kc relation. But in our textbook, they are given some of the examples. How will you find the delta Ng value? Examples, and also at least we have to write any one example. That is a must. Okay, so we can be find out delta Ng. How will you find out the delta Ng value? Delta Ng value, that is a product minus reactant value. How will you find out? Okay, let us one of an example. We can be consider one of the general equation. Hydrogen gas H2 gas plus iodine gas I2 gas, equilibrium reaction, both the forward and backward reaction, we get hydrogen iodide gas. H2 plus I2 gas gives hydrogen iodide gas. Am I right? So you have to balance the equation, 2 hydrogen, so make it 2 here. Equation is balanced. So these are all in gaseous phase. Don't forget that gaseous phase. Okay. Now, how much number of moles present in reactant and the product? How much number of moles present in reactant and product? As per delta Ng formula, product minus reactant. Am I right? What is the formula here? Delta Ng. There is a difference between the sum of moles of products and the sum of moles of reactant. So product minus reactant. Product is hydrogen iodide, reactant is H2 and I2. So product, which one is the product? Hydrogen iodide is a product. So how much moles of hydrogen iodide is there? 2 moles of hydrogen iodide minus reactant. Which are the reactant? Hydrogen and iodine. How much hydrogen is there? 1 hydrogen plus iodine 1. So we get 1 plus 1, that is equal to 2. Am I right? So we can be written as 2 minus 2. 2 minus 2 is equal to 0. Am I right? 2 minus 2 becomes what? 0. So delta, what is the value of delta Ng? Delta Ng is equal to 0. Okay. So we have to write the equation. What is the equation here? Kp is equal to Kc RT power delta Ng. What's the value of delta Ng now? 0. So Kp is equal to Kc RT power 0. Anything the power is 0 is 0. Am I right? So we can written as Kp is equal to Kc. Okay. This is about the first one. Same, we can do the second one also. Nitrogen. What is about the nitrogen? Nitrogen N2 gas plus O2 gas gives NO gas. So how to balance the equation? Gaseous state, am I right? So 2 nitrogen is there, so make it 2 here. So nitrogen balance, oxygen also balance. Next, how will you find out the delta Ng value? Delta Ng is equal to, what is that one? Product minus reactant. Product minus reactant. Product, how much moles is there? Number of moles is 2. So 2 minus number of moles in reactant, 1 nitrogen, 1 oxygen. So 1 plus 1. Okay, so what is the answer? 2 minus 2 equal to 0. So delta Ng becomes 0. So we get the same value. Kp is equal to Kc. Kp is equal to what? Kc. Am I right? Next one, how we can be discussed the next one. Next, another one example. Ammonia. What is the formula for ammonia? Ammonia formula NH3. Ammonia. Another one example. NH3. What is the condition? First condition is when delta Ng is equal to 0. Second condition, when delta Ng is equal to positive. Okay, what happened when delta Ng is equal to positive? Delta Ng equal to positive. Okay, for example, ammonia NH3, ammonia. This ammonia gas gives nitrogen gas N2 plus hydrogen. Nitrogen plus hydrogen. So you have to balance the equation. How can you balance the equation here? Nitrogen here, one nitrogen in the reactant side, product side 2 nitrogen. So make it the reactant 2. Am I right? So hydrogen, how much hydrogen is there? 2 into 3 is equal to 6 hydrogen. So make it 3 hydrogen. So what is the equation? 2 ammonia, 2 moles of ammonia gives nitrogen. 1 moles of nitrogen and 3 moles of hydrogen. These are all in gaseous phase. Am I right? Gaseous phase. So how will you find out the delta Ng? What is about the delta Ng? Number of moles of product minus number of moles of reactant. Number of moles of product minus number of moles of reactant. So product, how much product is there? Delta Ng is equal to nitrogen 1 plus hydrogen 3 minus here 2 moles of ammonia 2. So what's the answer? 1 plus 3 becomes 4 minus 2. So we get 2. Positive value. Am I right? Here what is the value here? Positive value. So we get positive value. Next, we can be write this value, delta Ng value to the relation. What is the relation here? Kp is equal to Kc RT. Here the value is positive, so we are writing positive. So we get Kp is greater than Kc. Okay, Kp is greater than Kc. Next one, PCl5 also same like that. PCl5, what is about the PCl5? Phosphorus pentachloride. PCl5, phosphorus pentachloride, gaseous state, gaseous phase. This undergoes decomposition. We get PCl3 gaseous plus Cl2 gaseous. Am I right? So how much moles? How will you find the delta Ng? Product minus reactant. Product. How much product is there? That is delta Ng is equal to product. Here PCl5 is 1 and Cl2, that is also 1. 1 plus 1 becomes 2. Minus reactant PCl5 is 1. So we get 2 minus 1. So now also we get the positive value 1. Am I right? Positive value. So when we are applying, we get Kp is greater than Kc. Yes or no? Next one, the last one. What happens when delta Ng is become negative? Delta Ng is equal to negative. What happens? Okay. So for that we are taking one of the examples. Hydrogen combines with oxygen, we get water. Hydrogen, H2. Hydrogen, this is one of the gaseous form. And react with oxygen, we get water molecules, H2O. So here 2 oxygen is there, so make it 2 water molecules. So 2 hydrogen, 2 into 2, 4 hydrogen, am I right? So Now, these are all everything in gaseous state, okay? Water is also gaseous state. Now, how will you find out the delta Ng? What is the formula for delta Ng? Product, delta Ng is equal to product, number of moles of gaseous product minus number of moles of gaseous reactant. Product minus reactant. Here, product, delta Ng is equal to number of moles of product, how much? 2 water molecules, 2 minus number of moles of reactant, 2 hydrogen plus 1 oxygen. So what is our answer? That is equal to 2 minus 3. So we get the, what is the value? Minus 1, negative value. Am I right? Negative value like that. One more example is sulfur dioxide gas. Sulfur dioxide. What is the formula for sulfur dioxide? Sulfur dioxide, SO2. SO2 gas. This on combines with oxygen gas, SO2 gas, on combines with oxygen gas we get sulfur trioxide, SO3, am I right? SO3 gas. So how can we balance the equation here? Oxygen, product side 3, reactant side 2, am I right? So how will you balance the reactions? Sorry, product side 3, reactant side 4. So just if you have multiplied the product side by 2 means sulfur also becomes 2, so 2 into 2 is equal to 4. Now oxygen 6, product side, reactant side also 6, sulfur 2, product side also 2. Now the equation is balanced, am I right? Now how will you find the value of delta Ng? Delta Ng is equal to product, number of gaseous product minus number of moles of gaseous reactant. Product is how much number of moles? 2 minus number of gaseous moles in product reactant side. How much? 2 plus 1. Am I right? So 2 minus 3 equal to, we get the minus 1 value. Am I right? So we get the negative value. So what's our condition? When delta Ng is equal to negative, delta Ng is equal to negative, just we can return the Kp value. Kp is equal to Kc into RT negative. So Kp is less than Kc. Kp is less than Kc. Okay. Okay, my dear children. This is our one of the very important question. Write the relationship between Kp and Kc. One of the 5-mark question. Book bag question. You have to write from page number 6 to 7. Okay, fully you have to write at least one example. One example, you have to write it. So, my beloved children, try to learn this question and write the assignment. I will check your note. You have to write the assignment. You have to take at least 1 times. You have to take written practice. Okay. Okay. Thank you all of you. Thank you. Have a nice day.